have the honor of introducing Mattia to you, who I've also have worked closely with, researched with, taught with. He does some of the best research, I think, in the community, especially based upon Apple and iOS. He's fantastic, but a brilliant mind, always willing to share. So Mattia, I will hand it over to you. Thank you for being here.
Thank you very much, Heather. Good morning or good afternoon. Here, I'm from Italy, so it's afternoon here. It's almost 5 p.m. I'm checking if I can control the screen. Yes. So who am I? I'm not the beautiful lady. I'm not neither one of the two nice dogs. I'm the weird beard man in the picture. I live and work in Italy, and I own, along with Francesco Picasso, a consulting company named RealityNet. We provide forensic services to the public and private sector. I'm also a SANS instructor for the 4585 and 4500 courses, and I'm also a researcher at the National Institute of Research in Italy. As Heather said, my field of research is digital forensics, and in particular, I love mobile forensics. I like iOS. And what I'm presenting you today is, to be honest, I'm the voice of a group of people doing and developing this research. This research was born as a project for the university, for a student, Francesca Maestri. I think she is attending my presentation. And then Francesca, with the support of Silvia and Claudia of my team, they did develop a great research. And the result of our research was also used at the last DFIRWS in Europe that we ran virtually in June for the DFIRWS Rodeo. So what we did basically is we tried to study a bit the Apple HomeKit. What is the Apple HomeKit? It's a software framework for home automation, where basically you can add to your home various types of Apple certified smart accessories. And these accessories can be grouped by rooms. They can be light, they can be sensors of various types. So we tried to study a bit this environment and which kind of traces you can extract from different kind of devices. The scenario that we built, it's quite simple, but it involves 3 different devices. The first one is a door sensor branded by Eve. It's a brand for door sensors. Then we used an Apple HomePod. The Apple HomePod was used as the home hub. So basically, it was the center of our Apple HomeKit system. And then we used an iPhone 7 as the mean to manage the entire home. What's the Apple HomePod? The Apple HomePod is a smart speaker, natively is a smart speaker developed by Apple, and it is designed to work with other Apple devices like the iPhone or the iPad, but it can also work alone, on its own, by with the interaction with Apple Music, and you can reproduce your music, you can have subscription to Apple Music, you can also listen to different radios and stuff like that. And moreover, it can be used as a home hub. It can be integrated with your home environment as a home hub. You can instruct your Apple HomePod with your voice, and the system that is used is Siri. So the same system you have on your iPhone. The second device that we used is a door sensor. This is a Apple compatible door sensor branded by Eve. It was physically mounted on the door of our office, and it was used for about 2 months to monitor the type of artifacts that were left behind on the various devices involved in this home environment. And of course, because it is connected to the Apple HomeKit, to the Apple Home, it is remotely connected and controlled by the HomePod. So let's start with some information about device identification. I tried to build a presentation like if you are in the field. And so you have to do the typical steps in digital forensics. So the first one is typically to identify the device. And this is true, typically computer and mobile devices. To identify an Apple HomePod, first, at the moment, there is only one model, so it's quite easy. That's an Apple HomePod, so you just need to recognize it physically. But you can also get the serial number from the bottom, on the bottom of the HomePod. This is a physical inspection of the device that can be useful later for correlation with information that you can find on other devices like the iPhone or the sensor. Of course, if you have access to an iPhone instead of the HomePod, you can also have a look at the settings on the Home app. The Home app is pre-installed in iOS, and you can see, if you have physical access to the phone, you can see information about the specific HomePod device that is connected to your home and to your iPhone. And also its characteristics like serial number, model, Wi-Fi address, and stuff like that. Oops, sorry. Then the second step, once you have identified, is to try to extract data from these kind of devices. And to extract data, I'm going to discuss both, so the HomePod and the iPhone. So for the HomePod, there is the most complicated kind of device in terms of extracting data compared to the iPhone. It's quite complicated and not easy. Is it possible to have a direct connection to the HomePod? At the moment, I would say no. We were not able to find any, I would say, commercial or something that was available to allow us a direct connection to the HomePod. Why? So first, there's no USB port, so that you cannot connect to the HomePod via a USB port. What was done, what we figure out by searching on the internet, is that when the HomePod was dismantled by iFixit, they found, that was 2018, they found these pogo pins, and these were supposed to be used for diagnostic testing. So after that, later in 2019 and February 2019, we saw, while we were doing our research, we saw this tweet, and that's these two tweets about this possible adapter to have access to a HomePod, to the HomePod, physically access to the HomePod via the pogo pins. At the moment, it seems to be a proof of concept. We were not able to find any implementation of this thing. So if there is any person able to do that or listen to this talk, so that's something that, I mean, I think it's interesting because we can connect and then get much more data. So as we were not able to directly connect to the HomePod, physically connect to the HomePod, we started thinking about possible different approaches. And one of the things that came to my mind was our research we did with Heather and Adrian last year on the Apple Sysdiagnose. The Apple Sysdiagnose is basically a system authorized by Apple to diagnose your system. And it is meant to be used by application developers to understand why an application is crashing or why the application is not interacting correctly with the device and stuff like that. I'm not a software developer, so that's not my main interest. Our main interest in studying this Sysdiagnose. But then we discovered that you can interact with a device and request the device to send you or to allow you to extract some diagnostic logs. And so especially when you have a device that you cannot interact with physically, maybe this was a good option. If you want to have an in-depth look to our research, this is the link. And there is also a GitHub repository owned and managed by Adrian, who developed, Adrian mainly with support of other guys, developed a lot of scripts to parse Sysdiagnose data. So here, if you want to go more in depth, but now I want to show you how we use the Sysdiagnose on the HomePod. So there is a specific Sysdiagnose profile for the HomePod. How does it work? So basically, you need to install it on an iPhone, and the iPhone needs to be connected to the HomePod. So basically, you need to have both the iPhone and the HomePod to get the data from the HomePod in this way, because you need the iPhone to install the profile on, and the iPhone can communicate with the HomePod. Once the Sysdiagnose profile is installed on the iPhone, and as you can see here, the profile is installed. Once it is installed on the iPhone, through the iPhone, you can trigger a Sysdiagnose on the HomePod. And this is done by using the Home app on the iOS device, and by tapping Settings, Analytics, and Export Analytics. That is a new button that will appear in your Home app only after you install the HomePod profile. Before, it's not possible. If you install the HomePod profile on your phone, then you have access to these export analytics. When you export your analytics, these will be something that runs on your HomePod. So some tools run, the diagnostic tools run on the HomePod, and the result will be a tar gzipped file that will be sent back to your iPhone through AirDrop. So basically, you have on the iPhone a tar.gzip file containing logs of the HomePod. So that's a good way that we found to get data from the HomePod. How can you get access to the iPhone? So that's a complicated question. It's full of presentations and great papers. I did a presentation for SANS, a webcast last week. It's free, available on the checkmate exploit and checkrain. I don't want to discuss on that, but that's what we did. We just did a full file system of the phone that was connected to the HomeKit system, and we used the script I wrote to get a full file system of the iPhone device. The script is publicly available here. There are a couple of nice write-ups based on my script. Also one recently written by Kevin Ripa on the SANS website. So have a look. If you have a test iPhone, that's a good and cheap, because it's free, option to test and to get a full file system of an iOS device. Use it only on test device. This is a script for testing. So data analysis, that's the most important thing and the most interesting thing on the iPhone. So on the iPhone, what we found is that there is one relevant folder and one relevant file that you need to analyze to get a proper understanding of the HomeKit system configured on the iPhone. The folder is called HomeD, and as typically it is in the private VAR mobile library. So it's a native app, so it's in private VAR mobile library. That's quite typical in iOS. Among the various files in the HomeD directory, the most interesting one is called datastore.sqlite. The datastore.sqlite, as the name suggests, typically it's an SQLite database. Among the various tables, the most interesting one is the record table. If we take the record table and we start analyzing it, also by making various comparisons and various testing, we were able to understand this point. So what you have to do, how to analyze this database. It's tricky, but it's not complicated. I try to explain, and I hope you can follow me. So table, record. What you need to do first is ordering by parent UUID, as you can see in the slide, and searching for rows where the parent UUID is empty. And typically, as far as in our testing, what you will see is that you can find a type named HMD, Home Domain, Home Manager Model. So the on domain Home Manager Model is a sort of the root of a tree, the tree of your home. And your home, as I told you in the first slide, is made up of different rooms. So basically, it's like having a tree where you have different rooms, and in the different rooms you have different devices. So that's how we are trying to read this database. So we have this HMD Home Manager Model. That's our pivot point, our starting point. We take this UUID, and then we order again the record table based on the parent UUID. And so here you see that we have a parent UUID that matches the UUID of the Home Manager Model. Among the various fields, the various types, we found some interesting information. One is the HMD Home Model, and the other one is the HMD Account Model. The HMD Home Model in particular contains, sorry, because I have the zoom and I have to move a bit, otherwise I cannot see the slide. Okay, so as you can see here, HMD Home Model, what you can see on the right side of the slide is that you have two columns named record and data, and you see there are binary large objects there. So if we take the HMD Home Model and the binary large and the UDID of the HMD Home Model and the binary large object in the data, this kind of binary large object is a plist file. If we open the plist file, what we will get here is the information about the home. So the basic information about the home. And I'll show you now in the next slide. And what we have here is the username, so the account, or the iCloud account, and the name of your home. That is, as you can see in Italian, la mia abitazione. That is, it's my house, my house. So that's the starting point. That's your house. So then you can also get, as you can see, geolocation of the house. That's interesting because if you find an iPhone, you can, by analyzing the data store and searching for HMD Home Model, you can get the plist file containing the geolocation of the HomePod. So basically and typically, the geolocation of the home of the device. Then we have, a bit slow. Yeah, sorry. I have some issues with the mouse. I think it's going now, yes. So then what you need to do is ordering by the new UUID. At this time, the UUID is your home. So we found the root that is your home, and now we have to analyze the various rooms and the various devices that we have in the various rooms. And at this level, the most interesting things are the field named HMD Room Model and the field named HMD Apple Media Accessory Model. If we go to the HMD Media Apple Accessory Model, I have some, it's a bit slow, but I hope. We have again to go into the binary large object to get the plist file. And this plist file, it's interesting because as you can see, it contains the information about the HomePod. So the manufacturer, the model, the serial number, and information about the firmware version, the name, and the MAC address, Wi-Fi MAC address of your HomePod. So this is again stored in the datastore.sqlite DB. So basic information about the device. Also, you can locate your device in the room, in a specific room. But why? Because you have a device. This device has an identifier, as you can see in this slide, B40B, blah, blah, blah. But also you can see room UUID, 3886F. So what does it mean? That this device, the HomePod, is in a room whose whose UID is 3886. So basically, the HomePod is in the bedroom. And as you can easily get it from the room UID and the the UID of the bedroom. And here is how the information is shown on the iPhone. So basically on the right side, you can see how it is shown on the iPhone, and on the left side, how it is reflected on the datastore SQLite. Now, the next point is to get the configuration of the HomePod. So we need the UID of the HomePod. That is, in this case, this 4952117C. So from here, we can analyze settings. And the game is it's again searching for the parent UID, order by type, get the binary large object, and get inside the specific settings. And just a quick view of some settings that we analyzed. That's the basic process of reiterating. So these are the music settings. There's an issue with the label, but it's music settings. And with the music settings, we can go into, again, the database and analyze the binary large objects based, too many effects. Yes, based on the plist. So basically, on the left side, again, the plist file containing the specific configuration of the HomePod, and on the right side, how you can see it on the iPhone. So how the configuration is reflected on the phone. The same for Siri. Siri, it's nice because you have various files. So various configuration. Do you want to allow, hey Siri? Do you want to allow to interact with your HomePod by saying, hey Siri, or touch and hold? Can you touch your HomePod to interact with Siri? Or does the HomePod have light when you are interacting with Siri and sound when you are interacting with Siri? And also the language and the Siri voice, and if it is like British accent, American accent, male or female, and stuff like that. Everything is in the datastore.sqlite. You also have another file that is the HomePod information. These are HomeKit configurations. These are probably meant to be shared with different devices when maybe there is a new device that is added to your home. And here you can find a lot of information in a unique plist file. The name, the serial number, the version of the operating system, the room, and stuff like that. So these are settings. Let's go now to the interaction with the HomePod and traces left behind on the iPhone and on the HomePod itself. So the first database of interest is the srdb.db that is again, on the iPhone, of course, private var mobile library, com.apple.siri.inference folder. There's this srdb.db database that keeps tracking of the interaction you did with Siri by, for example, requesting to play a specific song. So we have here different songs like Saint Cecilia. And here we found that the created and modified hat, these are the first and last time that this song was played by interacting with the HomePod on Siri. And because you are connected to your home with your iPhone, this information is reflected also on the screen of your iPhone, because you can interact with the HomePod also with the iPhone, for example, to adjust the volume or to move forward with a song and so on and so forth. So this database that is on the iPhone, it's interesting to get interaction, Siri interaction with the HomePod. The other database that we found is, as quite often, the Knowledge CDB. It contains specifically information about music that was played. And with this query, you can get information about songs that were played with the iPhone or with the iPhone in the system. What does it mean in the system? That we have a column named output device ID, and the output device ID is a binary plist file. And if we take a look at this binary plist file and we open it with a plist editor, what you can see is that there is a serial number string B40BD6, and that is exactly the identifier of the HomePod that we can get from the data store. So what we can get from here is that that specific song was played and the output device was the HomePod. So basically the iPhone and the HomePod were close one to each other, or or at least you sent a command to the HomePod to play the music. So that's interesting. Also, yeah, that's the identifier. And I'm moving forward quickly. And second part of our analysis was the Sysdiagnose. So we get the Sysdiagnose with the method I illustrated before. This is the root folder of the target zip file we obtained with the Sysdiagnose acquisition of the HomePod. Among the various files, we found references to preferences with the localhost name, so the name of the HomePod. We found references to Bluetooth addresses, the Bluetooth address of the device, and the Wi-Fi address of the device, and also the SSID and BSSID that the HomePod is connected at the moment in which it was acquired, but also as often happens with Apple devices, the traditional com.apple.wifi.plist, that is a plist file containing all the list of all the known network. That's interesting to know if the HomePod was used in different networks. It's not the type of device that you move, but maybe you had information of previously available network in the same area or something like that. And you can get also information about the access point. That's quite interesting. This is the Sysdiagnose Wi-Fi plist run against the plist file. And this is the output. So this is to give a great credit to Adrian Leung for its great work with the scripts, and also to Sylvia. She did great work in supporting and testing all the scripts. Mobile activation logs, they are really interesting because they can give you information about when the HomePod was turned on and when it was the operating system was updated and upgraded. That's interesting. You can have a timeline, and that's quite nice. The most interesting things, as always, and this is credits to Sarah Edwards for her great Apollo, you also have power logs. So power logs from the Sysdiagnose can give you a hint about volume, about timestamp of usage. Was the HomePod in use in a specific timestamp? And it's not always in use, the HomePod. It's not like the iPhone that you always use. The iPhone always interact with it. If you're not at home, typically you're not interacting with your HomePod. So you can see here, for example, some information about timestamps. And let me see that we were playing Air music, then we moved to Air podcast. And then let me see if we have here, like the volume, you see volume percentage. And you see here a whole from 9:23:21 to 9:35:49. So it means that the HomePod was not basically working in that 12 minutes. So you can build, and we were able to go back with power logs also some days back, so like 7 days or something like that. So that's interesting because you can get them with a Sysdiagnose. So you need to do it as quick as possible, this kind of extraction. And again, so these are also the bundle ID that we're running, so you can distinguish between, for example, the radio or Apple Music and stuff like that. The other interesting thing is the log archive. So basically you have a syslog of the HomePod, and here, if you search for process media remote, by ordering for this media remote, you can get which kind of thing the HomePod was playing. In this case, it was playing a radio at a certain timestamp. It's Beats one, it's the Apple radio. And in another case, we were playing a song, and this song is a song against Saint Cecilia that was playing on Buoncanile. That was the name of our HomePod. And here you have in the syslog the information about the song that was played. Again, we were able to go back at least a few hours, in some cases a few days, depending on how much the HomePod was in use. The Eve door sensor that was connected to our network, it's again tracked in the data store, SQLite. You have to do the same thing to search for the room, but you have to search for HMD accessory transaction. When you search for HMD accessory transaction, basically it means that you have an accessory in your Apple HomeKit environment. And in this case, we were able to get, as you can see, we were able to find the model, the manufacturer, the serial number. And that's easy. And the same applies to the room, in which room was the sensor. And here it is, the information about the room. I want to show you a quick thing. Again, same information can be found on the home data config, so the configuration of the HomeKit. The slides will be available, so do not take notes, don't worry. The app, so the device has its own app. So it is connected to your HomeKit through the datastore.sqlite, but it has its own app. And among the other information in the app folder, we have a plist file with basic manufacturer, model, and serial number. But more interesting, we have an SQLite database with timestamps. They can be converted, and every time you see 0, it means that the door was opened, and every time you see 1, it means that it was closed. So basically, on the right side is how events are tracked on your iPhone, and on the left side, you have the corresponding database. That's really interesting, because if you think about that, like having different sensors in the room, in the house, and you build a timeline of that, that's in some specific cases can be really, really, really relevant, because you can build a full timeline. And that's here. And you can also, you see the amount of time that the door was opened for 3 seconds, like in this case. That's another kind of interesting information you can get from the sensor. For findings and validation, and I'm going to close quickly, these are our findings. So first, it's an unexplored field in IoT and mobile. You can analyze, you can get data from both the iPhone and the HomePod. These are the list. This is the list of things we were able to find. There is for sure more that can be found, but this is a starting point. For validation, we tested our findings on Joshua Equan image, the iOS 13.4.1. And I'm skipping it, going very quickly, but just to confirm you that our findings are available and are correct in terms of we got the same results by applying the same methodology to the data store SQLite that you have in the publicly available Josh image. You see here the name, the username. There's no location. Maybe it's something that Joshua didn't authorize the HomePod to get the location. And I'm going very quickly just to show you that we were able to, of course, to find the information about the device, the model, the firmware version, the serial number, and the room UID, that is in the case, the office. So basically we rebuilt a bit Joshua testing HomeKit environment. And of course you can have other accessories and settings for the HomePod. And again, here I'm skipping, you can see that in the slide, these are his series settings. And we found that the language and the voice is English with US accent and a female voice. That's the configuration of the HomePod that was used in the testing environment of the Joshua image. And just the last thing, we were also able to get what Joshua listened with the HomePod. So basically we run the query against the knowledge C on the test dataset, and we get the list of songs that were played with the HomePod. How we did that? By searching for the output device, and on the left side in the binary plist, you can see the UDID of the corresponding HomePod in Joshua testing environment. And last slide, as a references, these are some of the references and some resources. And also, if you want to play a bit with this kind of stuff, this is public. This was the data set from the DFIR WS 2020 EU rodeo that ran in June. From this URL, you can download the device.zip, that it's the image of an iPhone. You can see a password.txt file, you can unzip it, and you can try answering questions. We have some tools suggested. You have the presentation of the rodeo, and I will upload in this folder also this presentation if you want to have it in the same place. And really last header, but it's really important because, as I told at the beginning, I'm the voice, I'm the face, but that's not a good choice. It was better if they put their face here, but I'm the voice. But Francesca, Silvia, and Claudia, they did, I would say, 90% of the job. It's, you know, when you are getting old, it means that you can support people researching, but they put a lot of efforts on it. So I want to thank them and to acknowledge them. And these are my contacts. You can find me on the Discord channel and on Twitter somewhere in the world.
Thank you, Mattia. Brilliant, brilliant, as always. And I know we're out of time. I did pin questions in the channel, but one that came up several times, people were asking, does this only work on like iPad OS, iOS, or will it also work on OS X? So if you can just take a second to answer that. Phil chimed in a little bit and some others did as well, but I didn't know if you wanted to talk about it here or in your hallway.
Yeah, I can. So I'm sure that you can connect your computer to your home. So I'm pretty sure that there are artifacts also on macOS. To be honest, we didn't analyze it. So if you have time, if someone have time to create a testing home and have a look at the macOS, so maybe the home D directory is a good hint to start. So maybe the name of the folder is similar on macOS. To be honest, I've not tested it, so it's something that needs to be tested.
Thank you. And now everyone's making fun of me for reading the exact question. It says OS X. How's that? How does the little raspberry sound in my microphone? Thank you, Mattia. That really was brilliant.
Have a good day. I'm in the Discord channel if you have any question.